A basic servo system is normally made up of electromechanical parts and consists of a synchro control system, a servo amplifier, a servo motor, and some form of feedback. While on the other hand, the position servo has the goal of controlling the position of the load. In the AC position servo system, the amplitude and phase of the AC error signal determine the amount and direction the load will be driven. In the DC position servo system, the amplitude and the polarity of the DC error signal are used to determine the amount and direction the load will be driven.
Servo system is classified as a closed-loop system when it is capable of accepting an order and defining the desired result. Accept evaluating present conditions, comparing the desired result with present condition, and obtaining a difference or an error signal, or issuing a correcting order and changing the existing condition to the desired result, and obeying the correct order.
The open-loop control system is controlled directly and only by an input signal. It has no feedback and therefore less accurate than the closed-loop control system. The open-loop system usually requires an operator to control the speed and the direction of movement output, while the closed-loop control system is the most common type used in the Navy. It can respond and move loads quickly and with a greater accuracy than the open-loop system. The closed-loop system has an automatic feedback system that informs the input that the desired movement has taken place.
Velocity servo is based on the same principle of error signal generation as the position servo, except that the velocity of the output is sensed rather than the position of the head. So when the velocity is at correspondence, an error signal is still present and the load is moving at the desired velocity. So the acceleration servo is similar to the velocity, the position servos, except that the acceleration of the load is being sensed rather than the position or the velocity. So in this loop, the tachometer of the velocity loop is replaced with an accelerometer. So that explains the velocity servos.
Damping is used to stabilize a system to minimize or eliminate the problem of overshoot. The simplest form of damping is friction clutch damping. Magnetic clutch damping is similar to friction clutch damping. The difference is how the flywheel is coupled to the shaft of the servo motor. Magnetic coupling uses a magnetic field to draw two friction plates together to produce damping. Another method uses the magnetic field set up by a pair of coils or one coil in conjunction with a conducting surface or the flywheel to produce damping.